Hello, I'm Hubert Ruczyński, and together with Anna Kozak we want to present you the results of our paper where we attempt to answer the question: do tree-based models need data preprocessing? In order to conduct this study for each of 25 machine learning tasks, we prepare 38 different preprocessing strategies and train almost 1 million tree-based models with the usage of the Forester package. The considered 25 datasets come from OpenML and OpenML CC18 benchmark and involve three task types being regression, binary classification, and multi-class classification. Furthermore, 6 of them have their quality diminished to mimic the real-life datasets. The newly implemented Forester's custom preprocessing module focuses on 3 major data preprocessing areas, namely the heuristic removals, data imputation, and feature selection. The first one consists of 6 separate removal criterion, which are aggregated into minimal, medium, and maximal removals. The data imputation involves mice, median other, median frequency, and KNN methods, whereas the feature selection algorithms are Boruta, Monte Carlo feature selection, mutual information, and variable importance. Based on those preprocessing methods, we create 38 different preprocessing strategies that are used in this study. The next step is the model training, where we also incorporate the Forester package. The train function is used for all 38 preprocessed versions of 25 datasets. Eventually, for each preprocessed dataset and every engine being decision tree, random forest, XGBoost, CatBoost, and LightGBM, we train 21 configurations where one of them has default parameters and the other 20 have their parameters chosen by the random search algorithm. Finally, we ended up with almost 1 million models for the whole study. To analyze the impact of data preprocessing strategies, we do not focus on the raw performance scores, but rather its comparison to the baseline results. The baseline preprocessing strategy consists of minimal removal, median other imputation, and lack of feature selection. The baseline dataset for the dataset is created with the baseline preprocessing strategy, whereas the baseline model is the best performing model trained on the baseline dataset. To validate how often given strategies improve or worsen the results, we analyze the number of wins, ties, and losses of all strategies in comparison to the baseline. Furthermore, we introduce the preprocessability measure. It describes how much performance can we gain or lose for a dataset by using various preprocessing strategies. The first column shows us the general impact of data preprocessing on tree-based models, and we can see that only for 15% of cases this step contributed positively to the outcomes. The feature selection methods tend to worsen the results, although the Boruta stands out and proves to be the most efficient one. The analysis of removal strategies unravels that we should not remove highly correlated features before using tree-based models, as the maximal approach, which uses this method, performs far worse than the simple counterparts. Finally, the outcomes indicate that KNN imputation works the best among the selected methods, with a remarkably high win percentage exceeding 50%. Additionally, we decided to analyze which models are more influenced by preprocessing. The decision tree and LightGBM mostly yield a negative impact, whereas random forest, XGBoost, and CatBoost benefit a lot. To validate our findings that describe which preprocessing methods work best with tree-based models, we decided to check how well the optimal strategy works out. To do that, we consider the preprocessing pipeline, which includes medium removal strategy, KNN as imputation method, and Boruta or lack of feature selection. Furthermore, we limited the results to the models that benefit from preprocessing the most, being XGBoost, CatBoost, and random forest. The outcomes show us that following such a preprocessing pattern leads us to the improvement of the predictive power of tree-based models. If we delve deeper, it comes out that in the case of 11 datasets, the performance doesn't change at all. Moreover, the highest positive preprocessability values reach up to 0.05 and are achieved mostly for the modified datasets. It indicates that preprocessing strategies are more useful when we deal with real-life data that is not perfect. See you at the conference.